record button. We are live. We are recording. Here we go.
Yes, sir.
So what are we doing today? We are starting. Oh my gosh, did it not save? Please tell me it saved. Oh, here we go. All right. So hopefully you guys can see that. We are lecture 4, guys. We are a third of the way there. That's crazy. Just a couple of things. Homework 3 is due tomorrow. How are you guys doing with the homeworks?
Yeah, I'm doing
Pretty good.
good.
There's like some steps to like the harder partial fractions that I still really don't get, but
Okay. Partial fractions as in like when there's like 3 parts as instead of 2? Are you talking about those?
yeah, like when you have to like substitute stuff in and like what's it called? Like I don't know how to explain it. Like when you make the like little equations.
The multiplicity handout?
Are you talking about
Yeah.
the trig one? The trig one?
No.
Trig
Hold
one?
on. Let's see if I can find the problem.
The multiplicity one. I think that was the one that we were doing.
Yeah, so I think China went over that multiplicity thing, and I actually went over an example in my video too. So if you're like, I go through a couple of weird cases in my video. One of them being like when the multiplicity is like more than 1 versus like when you have to use long division. But I think I said I'm not going to give that or the long division one or even the quadratic one. I'm not going to give those examples on your quizzes or tests, but they will show up in the fall.
Okay.
All right.
So just focus on like the canceling out one. That
Yeah, like the basic. I think the hardest one I give you is like, I think I give you a 3-parter when there's like 3 like binomials on the bottom instead of just 2.
Oh.
Yeah. So
Because the homework had some different ones.
yeah, I mean, we want
It's part of the textbook, yeah.
we want to expose you guys to as much problems as possible. That didn't sound right, but yeah, like we want to make sure you guys are kind of ready for the fall. That's all. But like I said, for this class with the quiz and exam, the hardest it gets is I give you 3 parts, but the idea is the same. You got to pick a smart X. You got to cancel out one of the variables and set up the equation. Yada yada yada.
Yeah.
All right. Your quiz 1 is also tomorrow. If there's time at the end. There should be time at the end, but I'm going to give you guys like a list of stuff that's on the quiz. I think I gave it to you already, but I'll give it to you again. And if there's time, we can like maybe even like practice a little bit, or if you guys have any questions or whatever. Any questions from me like right now, or anything you want me to relay to China or anything like that?
Yeah, I have a question for the quiz tomorrow. Are we gonna take it during recitation, or is it gonna be like a?
Yeah, so I'm gonna tell China to give you guys maybe like the first 10 to 15 minutes. I'll leave it up to you guys, like if you guys want to review more or less, but the first like 10-ish 15 minutes is gonna be the like a little bit of review or ask your last minute questions or say your last prayers, and then the last like 40 or so minutes, you're gonna take the quiz with your camera on. All right. We don't require you guys. I don't know if she does it in recitation, but we don't require you guys to put on your camera during recitation and stuff or lecture, right? But for quizzes and exams, you must. Okay, that's a must for us. All right. We had I heard there. I'm not gonna say who, but like there's another class where like people were like not doing what they were supposed to be doing during lecture. Someone apparently was watching like anime during a lecture. So if that's you, that's like super disrespectful, and I highly, they reminded us to highly encourage you guys to turn on your cameras during lecture, not just for that, not just so that we can like see what you're doing, but we can get like a better like read on you guys, like, feedback, body language, like I like it when I say something and then like, some people like smile or like cringe or whatever, like, just like I need like, I like that reaction, because it helps me, it helps kind of like dictate, okay, like, do I need to say that again? Do I need to like, can I go on faster? Things like that. All right. Actually, I didn't put it on my list here, but I'm actually going to send out a survey for that reason. Cause a lot of you, I'll be honest, I still don't even know like what you look like or like who you are. Like more than half of you, because like because the whole camera thing, like I don't know who you are, and like, or like you're just not participating enough or whatever. So this is your chance. Earn your 5% of this class. I'm going to send out a survey at the end of this class. I'm going to send it in the group chat. Please fill it out. It takes like 5 minutes. Be as honest as possible. It's just going to ask you, how are you doing, like, with this class? And then, like, is there anything I can do? Because I know some people, I get it, like, I'm too shy, right? Like, oh, I don't want to talk, right? I get it. It's fine. So now is your chance to kind of just like voice your opinion and be heard. Okay. All right. I think that was it for me. Any other questions so far about like integration or the chapter 6 stuff or anything like that? Because today
Shuban said something on the chat.
I don't see the homework options on Canvas. What does that mean? What homework options? Oh, do you mean like the assignment, the next homework assignment? Oh, did she not post up the problems? She usually does under announcements, doesn't she?
The chapter 7 ones were posted yesterday, like 7.7, 7.5. On announcements.
It's on her notes.
It's also, yeah, it's in her notes.
It's in her notes?
Yeah, you'll see it at the bottom. It'll say like Calc 2 PDF. You click that, it'll show it at the end.
Her notes are just showing. Oh yeah, yep. It's on the last page of her notes. She writes really small, but oh so neat. Oh my gosh, I can't even compare. All right, so that's your homework. So yeah, check the notes, Shuban, and yeah, you should be good. Any other questions like about integration? And it's only like we are giving you like less than an hour like to learn this stuff. It's on you to go home and actually practice it and try it. Okay, we're not expecting you to learn this all in this one lecture and that one recitation and like be like amazing at it. You need to put into practice. That's how it works, right? Sorry, I cut someone off. Did someone say something?
John, I just had a question. Like, I don't want to take up too much time of the lecture, but it was for 7.3, when we have the trig examples, there's always going to be a square root, right?
Yeah.
Or can there be cases?
Yeah, there should be. Because that's the whole point of trig sub, right? It's like when you're given a square root and you can't use u sub.
Yeah, okay.
Integration
Makes
by parts
sense.
and stuff.
And then for 7.7 is kind of like knowing. So you know how we put limit as r approaches a number, and then you replace that number with r for 7.7, the improper intervals?
The only time you would have to have r go to a number is when there's like an infinite discontinuity.
So when there's a discontinuity within the function, that's the only time you set
within
r.
your bounds.
Yeah, that's what I mean. Yeah.
Yep. Yeah, that's when you need the r thing.
So if it's like 3 to 6 and 3 is where the discontinuity is, it would be from r to 6?
You would need r to get as close to 3 as possible. So yeah.
Okay, so then it would be limit as r approaches 3, r to 6, and then the function?
Yes, and the integral. Yep.
Okay, yeah. All right, makes sense.
Anyone else?
In that case, I did ask China a question yesterday about like the notation, whether in Ali's example, whether it would be 3 from the left or 3 from the right. Is that
you don't need to note that, because the idea of limit is like the general idea of a limit is you're taking the limit from both sides. So it's like, so it doesn't matter. Like, I don't know how to explain this. Like when you say r goes to 3, we are taking like something to get closer and closer to 3 from both sides. But like we don't need the left side. Wait, am I mirrored? We don't need
Yeah, that's your right side when you do that.
Okay, we don't need the left side because we're coming in from we only care about what's going on from the right. If that makes sense.
Yeah.
Okay. Great questions. Anyone else? Let me just because can I get a check-in? Can you give me a thumbs up if you're there? Are you like listening and like you're good and we can move on? Like,
We're good.
I'm here.
okay. All right. Thank you. All right. So that's most of you. Some of you still didn't respond, but it's okay. Whatever. At this point. All right. Let's get started. Chapter 9 today. Chapter 8 is, oh, whoops. Chapter 8 talks about like more applications of the integral. I'll be honest, some professors do it, some professors skip over it. You know, it's kind of, it's like coin toss. I'm not going to do it just because we got much more fun things to do in here. So I'm just going to jump to chapter 9. And chapter 9 talks about differential equations. You guys have been exposed to differential equations before. I'm just going to kind of review them a little bit in some ways that like you should know what they are, kind of thing. We're going to do a problem or two and then talk about something in 9.4 called logistic growth that, like I said, some of you may have been exposed to, some of you may not have. Okay, so let's just jump right into it. We're going into, oh my gosh. We're going into 9.1. What did they call it? I think they just call it, solving differential equations. So I'm actually gonna switch over to my laptop here. Yes, and where is it? Oh, here we go. I'm going to show you guys something that should look familiar. Oh my gosh, why isn't this working? Oh, here we go. Can you guys see what's on my screen?
Yeah,
Yeah?
I remember that.
Yes, right? Those tiny little lines that you have to kind of like draw in and you're like, I don't remember what this means, right? Or
Slope field.
Yeah, these are called slope fields. Now, I'm not gonna test you guys on slope fields or anything like that. You don't have to worry about it. But slope fields are kind of like it's a way to use differential equations, right? If you don't remember differential equations, it's like you're given a dy over dx, and then some combination of x's and y's in an equation. In my example, I'm just doing x plus y. All right, and what that does is it generates, depending on where your point is, it generates a certain type of graph, right, called a particular solution. All right, it's like if I move the dot to, I don't know, over here, the graph looks like this parabolic looking thing, right? I guess hyperbolic looking thing, and the graph has to go through this one specific particular solution. Okay, so a differential equation on a coordinate plane, it's just a whole bunch of like particular solutions, right? It's like there's a general solution that you can find, and it represents all of these possible functions. Okay, so like if I move it over here, I move it here, like you notice that this initial point, this point that I tell it, it's going to dictate where the graph goes. Does this look familiar? Are you guys like?
Yeah.
You guys have done this before, and I don't need to.
Yeah, yeah.
Okay, so that's just one example of using, what the freak? Oh, sorry. That's just one example of using differential equations. All right, we're gonna use them in a different way today with logistic growth in a second, but we have to know how to also solve differential equations, right? So why don't I move to this guy? Oh yeah, okay. So in that example, right, I gave you, it was like dy over dx, or y prime, was x plus y. All right. However, okay, so some of you guys may have learned how to do this already. So I'm gonna see how much you guys know. If I wanted to find the particular solution, do you guys happen to remember like how to do it, or?
I believe I know how to do it.
Lamek, go ahead, man.
Okay, first things first, you're gonna do it in terms of x, and then you believe you add it, and then you do it in terms of y. You add it in terms of y.
Okay,
and I think you need a single point as well.
An initial condition. Okay, I'll give you one in a second, but I'm talking about just like solving.
Yeah, this.
You have to separate them in terms of the dy.
Who said that? Who said that? Was it Ali? Right.
Separating, yeah.
Yeah. So we have to separate them, right? It's if you guys remember, it's like we gotta shove everything with y's in it on one side, and then shove everything with x's in it on the other side. Does it make sense?
Yeah.
So watch what happens. I'm gonna move my y's to the left side because I'm so used to seeing that, right? So I'm gonna move this y to the left side, and then I'm gonna keep the x on the other side. Dy over dx minus y is
Hello?
equal to x. Hello.
Yeah.
Do you hear me?
Who is?
Yeah.
Yes.
This is Shaban.
Oh, okay.
Just making sure you guys hear me because I joined with my phone.
Okay.
now.
No worries. Yeah, I see it.
It feels finally good to know that I'm not the only one with mic problems.
Yo, trust me. I know you got like a handful of you have issues with the like if it's like bandwidth or connectivity. It's a lot of us. So don't worry about it. Where was I? Oh, okay. So do we notice something here though? Is there what's going on?
You have to multiply by dx.
Oh, okay. Let me multiply by dx. Let me get so smart, right? Because watch what happens. Dy minus y times dx is equal to x dx, and we're like, what happened?
Oh yeah. You also multiplied by y, so you can't get rid of it.
Yeah. So like if like we notice this dx is kind of like it's not going to go anywhere, right? It's going to stay on both sides, and that's a problem for us. So
What was the trick to this? I forgot what it was.
I actually, this whole thing was a trick. This was a lie. I lied to you guys. This is actually this is called a non-separable differential equation. Sorry, Lamek, I used you. I hope you can still be
Yeah,
friends.
it's okay. Okay.
But this is it's a non-separable differential equation, meaning you cannot separate the terms x's and y's onto one side, which means you actually can't solve this normally. And I'm going to use that term like loosely.
Could I try to say the answer? It's like I'm legitimately trying to remember the way to do it.
Yeah, I got you. It's fine.
1 plus y. We're trying to get y2 prime.
What's up?
Okay, 1 plus y.
Oh no, we're not deriving. We're not deriving.
Okay.
Yeah. We're actually integrating because we're trying to solve for y. Like we're looking just for like the
okay.
Y. So there are cases where you actually cannot separate the differential equation, and you need other techniques and other things for that, which are not covered in Calc 2. At least I don't think so. I think they only do, it's called first order differential equations. The crazier, harder ones to do, you'd learn that later on, maybe in like Calc 4 or whatever. But in this class, we are not expecting you to solve like particular solutions with non-separable differential equations. Okay, who's Alf? All right. So yeah, just watch, like, please make note of that. This is a non-separable differential equation. And I'll just let you know, the way you know if it's non-separable is if you see x's and y's being separated by a plus or minus. As soon as you see that plus or minus, it's non-separable. And the reason is this guy right here, what we just did, right? When you try to move the dx, it ends up like combining with the other terms. So you can't really do it there. Does that make sense?
Yeah.
So this means we can only solve for separable differential equations now. So why don't I give you one? All right. So I'll call this example 1. Let's say dy over dx is equal to negative y over x. All right. So this one, it's only dealing with multiplication and division. So we know that this one is separable. Is separable. So we can solve it. Why don't I give you an initial condition 2, right? Let's say the initial condition, I'll do IC for short, is 4, 0. All right, so here we go. I'm gonna separate all the variables, put the y's on the left side, x's on the right side. If you're feeling crazy, you could put the y's on the right side and the x's on the left side, whatever you want, okay? But I'm gonna put the y's on the left, x's on the right. This gets me dy over y is equal to dx over x. Oh, I forgot.
Negative y.
Negative, yeah.
Yeah, it doesn't matter where the negative goes. You'll get the same answer, I promise. I know we got trust issues, Lamek, but you can trust me.
Yeah, and I understand.
So at this point, right, we see a dy, a dx, which means, well, I can integrate both sides, right? The integral function, it's just kind of like, it's the same thing as if I took like the log of both sides, or if I raised both sides to the second power. It's a function that can be applied algebraically. So I can integrate both sides, And look at that, I have two integrals to solve. So my left side becomes
Natural log y
good.
and
Absolute
natural
value,
log
absolute
negative x.
value, absolute value.
Yeah.
Yes, can't forget that. I'll do it just for this one problem. Plus c equals the right side, which is,
Natural log negative x.
be careful, the negative's on the outside, and then plus another c. So like, so because there are like two c's, right? That means I can just take this c and just like bring it over, and it'll just create another c, right? So when you do these separation of variables, a plus c you can just put one on one side, and I'm just gonna leave it on the right side. So let me just rewrite this real quick. Ln of absolute value of y is equal to negative ln of absolute value of x plus c. We good?
Yeah.
Okay. I know it's been a while, but we got to get that y by itself. And since we got to get that y by itself, we need to solve for, I'm sorry, we gotta do something with that log, right? Do you guys remember how to like?
Yeah. E to the natural log.
Yeah. So, I mean, the proper phrasing is
What was it? Exponentiate or something?
We're gonna set the base as e for both sides. Okay. The only reason why I say that is because some people, they always like, they say like, oh, you just e it. I'm like, what the hell does that mean? What's e it? All right. You're gonna set the base as e on both sides. Okay. So that's, if you don't remember, like you set the two bases as e. And something cool really happens. On the left side, the e and the ln cancel out, leaving you with y. And yes, we can actually at this point just get rid of the absolute value sign because there's no more, for the lack of better words, like conflict with the domain. Like there's no more domain.
Yeah.
Once the e and the ln cancel out with each other. On the right side, we're gonna get e to the negative ln absolute value of x, and then the plus c is actually, it's all upstairs, that negative ln x plus c. And I can actually rewrite this again. This is going to happen a lot. You're going to see this, especially when you go over exponential functions, but in the fall, I'm not going to do that with you guys here. But this piece right here, highlighting green, that piece actually becomes like another variable because that e is a constant, and it's kind of like fiddling with that c. You know, it's actually going to end up becoming a new constant, and most places you're going to see it.
This one, John, I think it's easier if you just show it as e to the negative ln x times e to the c. I think it's easier to understand it. That's how we were taught.
Yeah.
Oh, I mean, I just assumed you guys saw it that way. Okay, all right, yeah, sure. All right, e to the negative ln absolute value of x times e to the c, like that, right? That's what you're saying?
Yeah, and then
yeah. So what I'm saying is like this guy is it's going to be its own like variable, and in most books, who was that, by the way?
Me.
Who?
Felipe.
Oh, Felipe. Okay, thanks. I don't know why you're not coming up. Oh, there you are. Right. Yeah. So in most books, you might see it as like B or A or whatever. I'm gonna just use A, and putting it all together, you get A e to the. Oh wait. Sorry. These cancel out, right? So
yeah.
We just get negative. It's just negative x.
1 over x.
Question? Can I ask a question?
1 over x.
Oh, it's 1 over x. Yeah, you're right. Yep. Because the e and the ln cancel out. Question. Who said question?
Oh, it's Philip. Oh, no, never mind. I see what you did there. I got it now.
All right.
John, what happened to the negative?
Something went wrong.
Because a negative to the power that goes to the denominator.
Yeah, this is the same thing as 1 over e to the ln of x.
Oh, I get you.
Right. So then the
Makes
e
sense.
and the ln cancel out, leaving you with just x, right?
Makes
Which
sense.
is a over x. Did I do this right?
I believe you did this right.
I think so.
I have a question.
I think I screwed up somewhere. This doesn't look right.
Did you simplify that to a over x or something?
Yeah. Who? Someone?
It was me, Shariar.
Yeah.
So for e to like when you did e to the ln, you were able to cross it out and just put y. But why not for the other side, for x?
You're talking about this piece right here?
Yeah.
We kind of did that. It's just because of that plus C, we had to account for that plus C first.
Okay.
So do you understand this step right here? Oh gosh.
Yeah.
Do you understand how this broke down that way?
How did the E to the C become A again?
So that was just okay. That was something that I just kind of labeled. I just said E to the C is A. I just made like a definition. It just turns into a new constant that's dependent on like E. So in most books, you'll see it as like A.
So now we start with the constants.
Yes.
What was the point again?
Oh, I think I said the
4,
initial
0.
value was 4, 0. So yeah, why don't we solve for the constant now? Something in me though. So this looks weird. I don't know if I'm doing this right. I hope I am. So 4, 0 becomes 0 equals 4 over x. No, something went wrong. We did something wrong here.
Isn't it A over 4?
Is it A over 4?
Wouldn't it be A over 4?
Oh, it is A over 4. I'm sorry. Wait, so then
Just
A
makes
over
it
4.
0.
So A is 0. Yeah, no, this is something went wrong. I think I know what I did. I was supposed to plug in the initial condition here instead of solving first. So I think I just lied to you guys again. Oh my gosh, Lamech, I'm so sorry. I think.
Yeah, the solution changes. You have to.
Yeah, I think we do have to worry about the absolute value signs. I thought we could just ignore them, but I was wrong. Oh my gosh, and it's recorded.
We finally learned.
That's bad.
We finally learned why the absolute value signs are important.
Yeah. I mean, they're also
John, I
important
had a
for other
question.
reasons. But yes, I heard my voice. I mean, my name.
Yeah, since we're using A as a constant, couldn't it still also just be C?
I wouldn't.
The fact that it's like E to the C kind of, it's like, it's different if it was like something being added to C, it would just be another C, right? But since it's like E to the C, you have to kind of redefine it. If that makes sense. It's like, it's too different.
Yeah, because when I learned it, my teacher just told us that we could just rewrite it as C because E is a constant, so just like the same.
It's kind of like, that's kind of true, but at the same time, for the purposes of what we're going to do in the next section, I'm going to say no.
Okay.
Let's wait till we get to the logistic growth, and then that'll maybe answer your question.
Okay.
Okay. All right. So where were we? Okay. So I apologize for that. We need to plug in the initial condition here. All right. So how do we know when to plug in? It's right after the integration step. So is that all right? So after integration step, plug in initial condition. Okay. And this should kind of like bypass any issues with the absolute value stuff. Okay. Where were we?
So yeah, plugging it in.
Oh, sorry. I screwed up from the beginning. I'm just not on my freaking game today. The initial condition is 0, 4, not 4, 0. I'm so sorry. Right? Because if I plugged 0 into ln, you would get infinity.
1.
Negative infinity, because ln of 0 is not possible.
Yeah, I know. Yeah.
Okay. All right. So we get ln of 4, and absolute value of 4 is just 4. So, and then minus. Wait, you can't do this either. What? What am I messing up on? Oh my gosh.
No, you have to plug in where y is equal to e to the negative ln x to solve for the constant. E to the c, that's what you're solving for at this point. So it's the step right after ln absolute value of y.
So you're saying what I had was right?
Yeah, you have to plug in at that step when it's y equals
I don't know.
e to the negative ln.
But yeah, because you changed the point. Remember, you changed the
because
point.
The e to the 0 has to be
plug
1.
in that other point.
No, but you still get ln of 0, which is not possible. Okay, I'm gonna switch the point so
Wait.
that this doesn't cause us problems. I think because it's okay, I'll just tell you guys. This is a family of circles. It's a whole bunch of circles, concentric circles, and then like with different radii. I think because I'm picking a point that's like horizontal or tangent. I mean, vertical with the circle, it's kind of causing problems with the ln. And in fact, I'll show you guys what
the graph looks
the
like.
graph thing, because when it tries to graph it, it actually, oh, I was about to say the bad word, messes up the circles. Yeah, I'll show you in a second. Okay, let's use 1, 4, and this should work now. All right. Oh my gosh. All right. So here we go. We plug in 1, 4. We get ln of 4 is equal to negative ln of 1. Thank goodness that's 0. And we get c is ln of 4, right?
Yeah.
We plug in c, and now we can solve for y. Ln of y is equal to, so I guess it didn't matter when you plug in. Ln of x plus ln of 4, right? Because if you just set the bases e, you get
y equals 1 over x plus 4.
Yeah, 1 over x. Negative 1 over x, right? No, 1 over x plus 4.
But now we could graph it.
Okay, so I'm not going to graph the particular
I have a
solution.
question.
Yes, who's I?
So,
Shubhan, hey,
Shubhan?
what's up?
Yeah. So, what happened to negative ln 1?
Negative ln of
Natural log 1.
ln of 1 is 0, right?
Yeah.
So it just goes away.
Oh, okay.
All right. Let me show you guys. What I'm trying to do here. Okay. So what was our thing? It was negative
y over x.
Oh my gosh. I gave you guys the wrong problem.
Oh no.
Oh
my god.
That's bad.
Wait, we can at least see what it's
This explains everything. This explains everything. Okay, I didn't give you a family of circles. I gave you a family of hyperbolic functions. That's why we're getting so many like weird. Okay, watch. I'll show you. All right, so it's a negative y over x, right?
Wait,
You guys
the
see?
problem? Yeah, negative over x.
Oh my gosh, I screwed up the problem I was supposed to give you was negative x over y, and that's the concentric circles. Oh my gosh, I'm so sorry, guys. Oh.
Should we go back up and resolve the whole thing?
Oh no, there's no time for that.
From the top.
No, not from the top. I will. I'll do the concentric circle one in the video, okay? Because yeah, I was like, okay, I was solving the
yeah, you fooled everyone, even yourself, you know.
I know, right? I was solving the whatchamacallit, the differential equation, and then our final answer kept being like 1 over x, and I'm like, why is it 1 over x? But this explains it, right? Oh man, that's so great. That's so cool.
Are we still getting quizzed on this?
Yes, you are. Okay, the steps don't change. Okay, I'm gonna go through the steps. All right, one more time. All right. So the first step is separate the variables. Okay, that's the first step. That's what we did here. We separated the variables, and then the second step was integrate. Right, and that's how we got the ln's and stuff. And then, so yeah, I lost faith. Oh my gosh. It actually doesn't matter when you plug in the initial condition. You can plug it after the integration step, or you could plug it in after you solve for y. Okay, it's totally up to you. You should get the same answer. All right, your C's might be a different value in the beginning, but at the very end, you should get the same answer. Okay, so if you want to do what I did and plug in after the integration step, you can do that, or you can solve for y and then plug in the initial value. Okay, so
yeah,
you're gonna plug in, solve. Step 4, I guess, is solve for c. And then step 5 is solve for y with the proper c value. Whew, man, that was not so bad. Apologies, guys. I make mistakes a lot, so.
Now we have it on recording.
Yeah. The recording might get lost, just letting you guys know. All right. Any questions on differential equations? I promise I will do a better example, a much nicer example of differential equations as a video. Okay.
Mm-hmm.
But it worked out, guys. It worked out. Look, it's a hyperbolic equation. I mean, even when like I lost faith, right? It's I don't know. Okay, whatever. All right. Let's move on to 9.4, which is logistic growth. Is it on your quiz? I'm pretty sure it's on your quiz. And on your midterm, there's going to be a separable problem. So you have to, once again, follow these steps, like separate, integrate, solve for C, and yada, yada, yada. Okay. 9.4 talks about something called logistic growth, and it relates to differential equations because it's a very specific type of differential equation that's very practical too. It's actually very it's used a lot. Oh, actually it deals with like, you know, how things spread too, like the coronavirus too. So we can talk a little bit about that, which is neat. I don't usually get to do that. So let me show you guys a quick example of oh gosh, the thing is in the way. Oh no. How do I, oh, there we go. All right. Can you guys see the Desmos graph?
Yeah.
Okay. This is a logistic growth particular solution. Okay. We're not talking about
like, yeah, Collins, how is he acting? Sorry. We'll go again.
Okay.
My brother came up in the room and I go again.
That's fine. So so this is a logistic growth equation, right? Like, can you guys tell me like what do you notice about this graph? Anything like the shape of it or anything like that? What does it look like? Does it remind you of anything?
Oh,
It starts growing, but then it like comes out.
Who said that?
And
what'd you say, man? Repeat that.
I said that like it followed like a pretty constant growth, and then a pretty exponential growth, and then it leveled out.
Yeah, it's like if I were to, if I were to like blot out the top half, right, of the graph, you'd be like, oh, that looks exponential, right? But then you notice it actually starts to taper off, and then kind of get asymptotic around, it looks like 60, right? So there's a couple important things going on here. Logistic growth graphs are much more practical than exponential growth. Because if you think about it, let me jump back to it. If you think about it, right? If I had an exponential graph, don't they all kind of like look like that, right? And we all know things in the real world don't go to infinity. That's not how it works, right? You can't have like an infinite amount of tigers in a tiger pen, right? Or whatever. Or like you can't have an infinite amount of people take up the world. Like what are some things you have to consider?
Like space,
resources, things available, right? Like what's available to you, right? So that's what logistic growth does. It actually paints like a realer picture, right? Like it's like saying like, what if we had a limitation on space? How would the graph look, right? And that's what the graph would look like. That equation that I just showed you before, all right? So, another important thing to consider here. So if this is a logistic growth graph, like where do you think the graph is growing the fastest then? You got to take a guess.
In the beginning?
In the beginning?
Yeah, like it starts out like explosive growth.
What am I asking here? If I'm asking for where it's growing the fastest, like what in calc terms?
Which slope is the highest slope?
Yeah, when is the slope the greatest, right? So, well, Lamech is saying is in the beginning, slope's the greatest there. Do you guys agree or disagree?
Sorry, can you say that again?
So Lamech is saying the slope at the beginning is greatest out of everywhere.
No, I'd say it's in the middle.
You say it's in the middle, like about there?
Yeah.
Yeah, I think I would agree. Why don't I just tell you guys, right, the difference here between exponential and logistic. Okay, exponential functions. You guys learned this. Have this going on for its differential equation, k times p. The amount of population there are, well, it'll be affected by some constant k, right? But that will determine how fast the population is growing. The more people you have, the faster you populate. Make sense?
Yeah.
Right. But logistic growth is going to throw in like kind of a curveball. It's going to look like exponential, like we said, but there's this new like limiting factor, right? There's this new limiting factor that's going to stop the population from growing too fast. And that's what this piece is for. You'll see it look like this. Okay? M minus P. And what M stands for, what M stands for is it's called carrying capacity. Some of you may have heard of this.
Yeah.
Carrying capacity, meaning like, you know, how many bacteria can fit on a petri dish, or how many, I keep going back to lions because the freaking Tiger King show, but how many tigers can fit in a pen, you know, like things like that, right? So that's the difference here. And I hope I kind of made that clear with the graphs and with the equations, right? This is the curveball that logistic growth deals with. Now, man, usually at this point, I do the proof, okay? You guys can probably guess where this guy comes from. Right? That should look familiar. You guys probably learned that in pre-calc or something like that. But the way on how you got there is actually we separated the variables and solved for P. Right? If you guys can see that, right? All the P's on one side, all the T's and DT's on the other side, and then we're going to use ln, and there's going to be blah blah blah. So I usually show the separation of variables on the logistic growth part, but I'm actually going to do that in the video because it's a little long, and it's actually really cool. Like, I would really like it for you guys to watch it. I'm not like trying to like toot my own horn, but like the proof for it is actually like really cool. Okay, I'm going to show you the formula. Don't freak out. It's a little crazy, all right? But it looks like m over 1 plus ae to the negative mkt. So if you
why did they put the e at the bottom when they could have?
Okay, so if you have any questions on where that comes from, check out the video because I don't have time to do it in class. I'm sorry, but
okay.
But yeah, okay. What does this mean? Yes, you need to know these two formulas. Just memorize them. Honestly, at this point, just memorize them for the quiz that's tomorrow. Okay. You have to know what the variables stand for also, right? So like I said, I'll say it again. K is your growth or decay factor. M is your, I said it already, carrying capacity. P is just your population, right? That's your output. And then T is time, right? So as time goes on, population should be increasing or decreasing depending on, yeah. So to kind of make it like a little bit more relevant, I'm just gonna say my little piece here, right? Like what's been going on with the coronavirus, right? Like you can imagine, like if that's what all logistic graphs look like, okay? I'm talking about like a localized area, maybe like state to state. I'm not talking about like as a whole. It might look logistic as a whole probably, but you know, Texas and Florida, they be messing up like crazy. But yeah, so like from state to state, it should look logistic, right? If we are following proper precautions and all that jazz, right? Like this is the beginning, right? This is probably where like Trump said like, oh, it's gonna get better, but then it didn't, right? And then it keeps on going up. And eventually, once it's contacted with enough people, it actually starts to taper off and stop.
Herd immunity.
Or yeah, whatever you think. But yeah, but because some people don't follow proper precautions, right? What ends up happening is it actually ends up spiking up some more, and then the tapering part falls later. And what people are doing is they're prolonging that by not following directions, by eating out, like going to restaurants when they say not to do that stuff. All right. So please don't be that person. Okay. I know it sucks right now. I can't imagine what you guys are going through just at home, like all the time. Oh,
John, can you scroll up a little?
oh yeah, my fault. Is that good? More? Menos?
Good. Yeah, you're good.
Okay. So yeah, so that's pretty much like what's kind of going on right now with logistic growth. In fact, there's a really cool video. I don't know if you guys know, there's a channel on YouTube called is it like 3 blue, 1 brown or something like that? 3 brown, 1 blue. Anyone? No.
That sounds right.
It's either 3 brown, 1 blue, or 3 blue, 1 brown. They have a really cool video on logistic growth and the coronavirus and like how it's spreading and all that stuff. So you should check it out.
It's 3 brown, 1 blue.
It's 3 brown, 1 blue. Okay, thank you.
Wait, 3 blue, 1 brown. I don't know why Google allowed me to just be right for a quick second, but it's a 3 blue, 1 brown.
Okay, 3 blue, 1 brown. Okay, thanks, man.
Could you scroll up real quick to the graph? I just want to see how the graph looks.
Why don't I show you the example? I think that example would be better because my graphs are not that great. So if you notice this graph, it looks very symmetric, right? In the middle is where it's going to be growing the fastest. So that's when dp over dt is going to be the greatest, right? And then, and please note, this graph is a particular solution. This is not the slope field, right? The slope field would have a bunch of these little things, right? Actually, let me show you guys. I wonder if this is going to do it. Did it change tabs on your end?
Yeah.
Can you guys see that? Okay. So what do we have? Give me a growth factor. I don't know, like 0.02. Whoops. 0.02 times. I guess it would have to be y, and then a carrying capacity of like 4 minus y. I hope this works. Okay, you can't really see it because it's like, whoops.
The min and max. And
it's like zoomed in too much. You can't really see it, but like.
Try changing the min and max.
The slope field only generates on a certain like part of the graph. It doesn't do all. You know what I mean? It only does like that piece. So yeah, you can't really see it. Sorry. All right, that was a bad idea. All right, learning a lot today about this. All right. Okay, so going back to it all, John, how are we gonna? What are these problems gonna look like? Can you just show us the problem already? Yeah. All right. Fine. So once again, look for the video. I'm gonna go in a little bit more detail on where this function comes from and stuff like that. Okay. Let me just get rid of my scribbles. And let's look at an example here. I'm looking at. Oh, I forgot to say. In the fall. So this is the way I teach it. These formulas are the way I teach it. Your professors might use different looking formulas, but be rest assured they look exactly the same. For example, you might see this one look like y of t equals a over 1 minus e to the negative kt over b. Why are there different forms? Well, it's just, for different purposes, okay? But they all mean the same thing, okay? There's always going to be a carrying capacity. There's always going to be a growth rate, and there's always going to be an initial condition, okay? Yeah, so this one, there's another form that you might see. It's like k y 1 minus y over a equals dy over dt. Okay, so that's the differential form. This is the particular solution. It's just a different form, but once again, they all mean the same thing, right? There's always going to be a growth factor, and then the carrying capacity is always going to be there too. Okay.
Yeah.
I would definitely ask China because she's gone through the through Calc 2 much more recently than I have. Ask her which one is more like popular, definitely, because I have no idea. All right, let's look at an example now. We're going to look at example 1 on page 530, 540? 539? No, 541. Okay, so we're looking at example 1 on page 541. And once again, this is the PDF page. This is not the actual page in the textbook. So example 1, it says you have a dy dt, you have a differential equation. It looks like 0.3y, 4 minus y, and then an initial condition of 0, comma 1. All right. What do you, Frankie? You're looking real comfortable there. What do you guys think we're gonna have to do if it says solve, like solve for y? What do you guys think?
By itself, like how we did the 9.1 and 9.1. Put y forth by itself and everything, and then integrate and.
Right. Okay. So Lamek, you're technically right. You can separate the variables, you can integrate, and yada yada yada. But I'm gonna do that in that video. Okay. In the video, you do that on the general equation to get to that, to the particular. So what that means is I'm gonna say just.
Oh, you use the equation.
Yes.
To
use the equation.
Okay.
So what does that mean?
Okay.
That means you have to figure out your carrying capacity, right, and your growth rate. And you can tell which one is the carrying capacity and growth rate, right?
So it's going to be 4 over 1.
Hold your horses, right? So 4 is m, 4 is your carrying capacity, and it looks like your k value is 0.3. Okay. So yeah, go ahead, Lamek. What do you think our p of t is going to be?
4 over 1. Okay, I'm gonna use the.
Can you use mine? Can you use mine? The one.
No, cause like a.
What?
A, cause like it's a, and I'm like.
Yeah, plus. So it's 1 plus a e.
Oh, let's leave it like okay. 1 plus a e to the power of negative 4 times 0.3 times t.
4 times 0.3 times t. Great. If you're unsure about what that a is, it's the same a as the.
Yeah, I realized that, and I was like, I realized that I was just like a brain fog for not knowing for no reason.
No, that's a good point. I don't think I properly defined a anyway. So a is going to be like, it's going to come from your initial condition, right? We're going to plug in the initial condition and then solve for a and get our graph that way, or our equation. So here we go. We used the two formulas. We figured out m and k. We plugged in. Let's plug in our initial condition and see what we get. So it looks like t is 0.
Yeah, so that means e to the power 1.
E to the power 0, right, which is 1. So this ends up being, so p of 0 is 4 over 1 plus a equals, initial condition is 1, right?
Yeah, so 1 plus a equals 4, a equals 3.
And so our particular solution, putting it all together, ends up being 4 over 1 plus 3 e to the, what is that? Negative 4 times 0.3. That's 0.12? Negative 0.12?
Question.
Or negative 1.2. Yes.
I have a question. Yeah. So how did you get a equal to 3? Because that's 4 over 1 plus a. And then you have equal to 1.
Right. So we multiplied both sides by 1 plus a. Right. And then we get 4 equals 1 plus a. Or you can think of it as like 1 plus what gets me, like when I divide that into 4, it gets me 1. So it has to be 3.
How would you get rid of the e to the negative 4?
We plugged in 0 for t.
Oh.
So if t is equal to 0, it's e to the 0, which is just 1. And then How are we doing? How is this? Minus the algebra
Makes
part.
sense.
Make sense?
Yeah.
Okay, let's see if anyone's watching.
It's like once you like identify the M and the K, then
Yes.
then it just becomes easy.
Yes. Okay. So I gotta warn you guys, it's not always going to be as clear as this one, right? This is because it's example one, right? Example one's always easy. But if I give you an example like just a quick example like this one, like if I give you 2y, 1 minus t over 4 is equal to dy over dt. If I gave you something like this, could you tell me what the M and K are?
I believe M and K, right? I'm just looking at the formula right now. The K,
Okay, K
it could be
is
2. M is 1. Wait.
So, okay, you got to watch out. Like, if you're gonna use this form, right? If you're gonna use that form to dictate your M and K, it has to look like that form. Does this look like that form?
Would K be 8?
No,
where is that
it
coming
looks
from?
like
Who said
dy
that?
over dt.
I did.
Don't say I, because I don't know
Rohan,
who's
sorry.
talking. Who? Rohan.
Mhm.
Okay, Rohan. What did you do? How did you come to that
I
conclusion?
just got rid of the denominator 4, so I just multiplied by 4.
Right. So what Rohan did was, I don't know what to call it. I don't like, technically it's factoring, but it's not like factoring what you're used to seeing. I call it force factoring because you're forcing a 1/4 out of each term. What does that mean? So I'm pulling out a 1/4 out of the 1 minus t over 4, right? So that would mean this has to be a 4, and this would just be t. Do you see what I did there? Like if I distribute this back in, I get 1/4. I'm sorry, 1 minus t over 4. Now I have a 2y on the outside.
Gonna be 2 over, so K is 2 over 4.
So k
M
is
is
1/2. Yeah.
And
So you were close, Rohan. Off by a little bit there. Okay, but that's kind of like an important point. Like if you 1 second, if you're not given the proper form, or if you're using this form and like it doesn't look like that form, you have to kind of take the proper steps to kind of rewrite everything.
Okay, so the question is 2y times 1 minus 4 over y.
The question is, yeah. I'm not using p anymore. I'm using y, so it's just a different variable. That's all. Right. The important part of this one was I was just showing you like you may not always get that form, and you have to like rewrite it so that it is in that form. Okay.
Yeah.
Can you scroll back up a little bit?
Sure.
Okay.
So we talked about carrying capacity. We did that one. I'm gonna leave the second example in the video too. It's about like most population, but it follows the same thing. Okay, so I'm also gonna do that in the video too. Okay. Shoot. Okay, so I have negative minutes left. I want to give you guys the quiz topics before parting with you guys. So why don't I do that real quick? And yes, the stuff we learned today is going to be on there tomorrow. All right. So 6.1, 6.2, 6.3. That is the area and volume stuff. Okay. Can you find the area between two curves? Can you revolve stuff around an axis? There is no shell method on there. There's no like where the cross sections are semicircles. That's not on the quiz. Okay. But it might show up on the midterm. Okay. There was an example I told you guys to like watch out for in 6.2. That's going to be on the midterm, not on this quiz.
When is the midterm?
You should know that. I'm not going to answer that. Chapter 7 was techniques of integration. 7.3, 7.5, 7.7. So it's probably going to be like one problem of each, essentially. Okay. So these are the integration techniques, right? Oh, not U sub. What do we start with? Parts, right? Integration by parts.
Tabular method.
There might be a tabular method on there.
Trig sub.
Thank you. U sub, no, not so much. What am I forgetting?
Improper integrals and
improper integrals, yeah.
The partial fraction one.
And partial fractions. Thank you so much. Right? There's probably going to be one of each on there.
Can trig sub be easy, please?
So like I said, trig sub, there will always be like a beautiful part where everything cancels out so nicely, and then you're going to integrate and then get an answer that way, okay? I promise it's not going to be like that one we just did today. Oh yeah, 9-1. So separable differential equations. Separable. I'm not giving you non-separable. There's stuff you can do with non-separable. You know, there's something called Euler's method. Maybe some of you learned it already. But we're not going to play with non-separable differential equations. We are only going to separate them and then integrate, solve for the C, do what we did today, okay? And then, and of course, logistic growth, which is what we just talked about today. You have to know the two formulas. You have to know how to identify your M and your K values. Yeah, I might even throw in like a, like come up with your own scenario type of question on there too, okay? With a logistic growth.
So we can or we cannot use the COVID-19 for that problem.
I guess if you want, I don't know, try and be original,
Yeah.
There's not that many times I ask you guys to be so creative.
Wait, what does that say for after the chapter 7 int something?
Integral techniques.
You're just hitting on my fast writing. Integration techniques. All right. So what I'm going to ask you guys to do, because I know I'm going to forget if I don't say it right now, is fill out a survey. Oh my gosh, why is this not?
You're gonna put in the chat.
Yeah, I'm gonna put in the chat just so you guys can just readily click on it, and it's gonna take a couple minutes. All right. I really hope everyone participates, and so I can get proper feedback from each and every one of you, especially the ones that don't talk too much. So yeah, please fill it out when you can. I would say by the end of today. Yeah. Watch out for your homework due dates. Watch out for the next quiz, or when is the midterm? It's the 15th, right?
15th.
Yeah. So make sure you guys know your due dates. I'm not gonna baby you guys. All right. You have to know your dates. All right. But yeah, that's it for me.
Wait, for the forms, does it go by account? Because it doesn't say anything to put our name. It doesn't say anywhere to put our name.
Oh, mother freaking. All right. Can you guys do the form in like 10 minutes then? Because oh my gosh, I can't believe I forgot to put that there. All right.
I mean, like, I guess we can like put it in the first question. We could just put our name.
Hold on. Okay. Exit out of the form, and then go back into the form. It should. I just changed it.
Yeah, it's there. It works now.
Okay, thank God. All right. Okay. If you guys want to stick around, you can. If you are good, you guys can leave. I'll see you guys
bye, John. Thanks.
Friday, and good luck on your quiz, guys. Please study.
Thank you.
Bye, John.
Bye-bye.
John, I had a question.
Yes.
Is it cool if I give you a quick problem for 7.7 that we can like kind of go over?
Oh yeah,
Not
that's
like
right,
the whole
right.
thing.
I forgot. Yeah. Mm-hmm.
Yeah.
Wait, question. Wait, Philip. I'm having trouble reaching the textbook, the calculus textbook.
Are you in like the shared? Did you use the shared link or whatever?
I don't know where it is. That's my problem.
It should have been emailed to you guys, no?
Pretty sure it's on.
The thing, it was also in the group chat.
So I have to go on group me?
Yeah, the group me.
Yeah, it's on the group.
I definitely had it on the group me. That's where I got mine the first time. I don't know about the emailing thing, but like I know for a fact it's on the group me.
Okay.
And
how about this? I'll put it up in the as an announcement. How about that?
Yeah.
Okay. Someone driving?
Sounds like a blinker.
Oh my gosh.
Okay, I see.
Yeah,
it.
that's me.
Y'all are crazy.
It's
Okay.
cool. I'm not holding.
Okay, I saw it in a group me.
Okay.
John, I have a question.
What's up?
You said you sent out like a survey.
A survey, yeah.
I think because he can't check his phone, like he's in the chat.
Okay. Then I will put the survey as an announcement too. Then, right?
Hello.
Harry, can you hear me? Hello.
Yeah. What?
Harry, you
I
there?
don't think he can hear you.
All right. Hopefully he sees that. All right, Ali, what's up? What's your
So the one from the homework that I wanted to see was 38. It was the integral from 1 to 2
the integral from 1 to 2
dx over x ln of x.
dx over x ln x?
Yeah.
Oh, oh boy, this one. Yes, I love this one. So dang, how do I don't want to give it away because that's no fun. What are your let me hear your thought process. I want to hear
So
like
what I first did was I did u sub, right? So I did u equals ln of x, and then du is equal to 1 over x dx. So then dx is equal to x du because you want the x's to cancel.
yes.
So then
Your
after I
left
did that, I got 1 over u du, like the integral of 1 over u du.
Sounds good.
And then it was ln u, and then when you put in u, it's ln absolute value of ln x.
Like that?
Yeah, but I put in what u was, if that makes sense.
Oh, okay.
So then I went to creating like the limit. So I put the limit as r approaches 1 is the negative integral from 2 to r, because r is usually on top, if that makes sense.
Say that last part again,
1 0. Wait, that's
What I did was the limit as r approaches 1 is equal to.
Why do we need a limit though?
Isn't it because like at 1 you can't do it because ln of.
What's it? Don't say do it. Do what? What does the graph of ln look like?
It's just exponential, so it's like.
Sort of. Looks like this.
Yeah.
What's that point right there? What's that x value?
ln of 1.
Which means 1 is in the
so
domain.
It's 0. Okay.
Yeah. However, something weird's gonna happen when you plug that 0 into the next ln. Right?
Yeah.
So this one's kind of weird. So this one's gonna be ln of 2 minus ln of 1. Whoops. Right. So this one's gonna be okay, but then when you get to this step, ln of 0 actually is negative infinity because as you get closer and closer to 0.
Oh, it's negative infinity.
So the answer is actually like it's like divergent. Or
okay,
like you can say like
because it's not a finite.
It's not a number. Yeah, it's not going to be a number.
Okay, yeah. Because I was because ln of 0 is that's what I was kind of confused about. So the limit's only when there's a discontinuity, correct? I don't know why I did that. Now that I think about it.
In 7-7?
Yeah, number 38. Like this problem.
Oh, okay. Then actually you might need to do that then, just to kind of like prove it, because I kind of just said it. I didn't really like prove it in my work. We can try it. Let's see what happens. So if you have the limit as r goes to, that wouldn't be 1, right? Yeah, no, it would be 1. Yeah, so then you have, oops, no, that's still 1. So it's like ln of 2. So that piece is going to be okay, minus ln of r. Right?
Yeah.
And as ln of r goes to 1, yeah, this goes to 0, and as it gets closer and closer to 0, this is going to become negative infinity. So yeah.
Okay, yeah.
That works.
Because when I was at that point, it was like I thought it was just D and E, so I was kind of confused on what to get.
In this case, we're gonna say that it gets closer and closer to negative infinity, which is divergent. So
Okay,
you would say
so
this.
regardless, the answer would still be, well, it would be divergent, yeah.
Yeah.
Because of the negative. All right, it's cool if I could take a photo real quick.
Yeah.
Could you show it on a little bit? No, down, not up. Yeah.
So on the test, or whenever this appears like on a quiz, do we just write diverges? Or do we have to write diverges to negative infinity or positive infinity?
So you can write diverges or divergent, but you have to show proper work. Like all of this is required.
Oh, okay.
Yeah, you can't just say like diverges. Like you need to like prove it. Like with your work.
Yeah.
John, the last one was, it's kind of like I don't want to say broad, like general, but for like 28, it was the integral from 3 to 6. And then x dx over the square root of x minus 3. So when I did this out, like with u sub, I got that x equals u plus 3. Now, I like vaguely remember when you get a scenario like this, do the limits like switch or like move over or something?
So it all goes back to that whole coaster idea that I said, right? Like you can't be rude, right? You got to make sure that whatever variable you're integrating or whatever stays consistent through your whole entire problem. So if you want to change everything in terms of u, you have to also change the bounds. Or you can change it back to x after you've integrated.
Okay.
Right? But you have to keep consistency in your work. That's the key thing.
So the best thing would be to change it like before you do everything, because you're doing it.
Yeah, this one's kind of tricky, right? This one's like u equals x minus 3, right?
Yeah, in order to cancel, you need...
You have to have a u plus 3 on top, and then it's over like that?
Yeah, I got u plus 3 du over square root of u, yeah.
Oh, wait. But what's going to happen with the du? Nothing, right? Du is just du?
Yeah, it's just du because you have the plus 3 with the u.
And then is this integratable?
I got... the end result was 2, and then when you plug back in u, well, I'll tell you in terms of u. I got 2u to the 3 over 2 power over 3 plus 6u to the half power.
What section was this in? Integration by parts?
7.7. Yeah.
This is
the improper integrals.
Improper integrals.
28.
Oh, because you have to let r go to 3. Right?
Yeah, but the thing was, like before that, it's the limits. That's what I was like. I kind of forgot what to do.
I think you can just do this one by parts, right? You're going to integrate it by parts, and then, right? Because u is going to be x, and then dv is going to be root x minus 3. And then you can integrate that, right? This is going to become x minus 3 to the, you add 1. So 3 halves with a 2 over 3 in front.
Yeah.
And then you integrate it one more time. You get x minus 3 to the 5 halves with, what is that? 5 halves is 2 over 5. So it's 4 over 15.
Mm-hmm.
So I think this one is, you can use integration by parts, and then you plug in the r with the 3, and then plug in 6.
Oh, okay.
What so was there another way? Did this way work?
But yeah, I did it in terms of u sub, and my only thing was that, like, I would have gotten it, I'm pretty sure. It's just I didn't know what to do with the limits because of the x equals u plus 3. Like, how would you change it? Like the steps towards it, I guess.
Well, you just plug in you plug it into your substitution, right? If x is equal to u plus 3, then you just plug in 3 for x, and you get it in terms of u. So u is going to be 0. So this would be u equals 0 to 6.
Oh, that makes sense.
Which is 3. So it's
from, so then the new bounds are 0 to 3.
0 to 3 in terms of u, yep. But my question to you is, how did you integrate this?
I just did, what's it called? So I separated it. I did, so you know how it's u plus 3 over square root of u?
Mm-hmm.
So since you can add them, you can like take away,
like that, right?
Yeah, and then it would be u to the half plus,
I get you. Yeah, yep, that works.
Okay, yeah, now that makes sense. Okay. Yeah, that's about it for 7.7.
Cool.
I'm just gonna do practice problems just to
Cool.
get that down. I'll be chill.
Nice. I'm expecting some great things from you, Ali.
Thank you.
Have a great day.
I'll see you, man.
Thank you, John.
See you. See you. Everyone else, are you still there? Oh, no. Oh, they're peacing. Okay. Bye. Bye. Bye.
Bye. See you.